Okay, great. Thank you, everybody, for holding. A few more people did log in, so I'm glad we waited for a couple more minutes. We will go ahead and get started now. Thanks to everyone who has intrepidly agreed to attend to today's webinar after what for many of us was a long night of emotional roller coastering. I appreciate everybody being here today. Today's webinar is ScyllaDB on Compose. My name is John Silvers. I'm with Compose, and I'm one of the organizers for today's presentation. In a minute, I will introduce today's speaker, Eyal Gutkind, who is at ScyllaDB. Today's call will be in listen-only mode. You can ask questions using the GoToWebinar panel on your screen. We will come back at the end of the presentation to answer questions if there are any. We are recording today's webinar, and we will send everyone who registered for it the link to the recording by the end of the week. I wanted to briefly introduce Compose for anyone who's watching who's not already a customer or who hasn't signed up for a free trial. Compose makes it easy for developers to use production-ready databases for building apps without all the hassles of managing the databases. Each database is deployed in a high availability cluster. What our customers tell us is that with Compose, they can focus on writing apps and not managing databases. We offer Compose both as a multi-tenant hosted service on AWS, GCP, and SoftLayer. We also offer Compose Enterprise, which has all the same goodnesses as Compose multi-tenant, but on your own servers, on your own cloud servers on AWS or GCP. We've been around since 2010. Back then, we were called MongoHQ, and about 2 years ago, we changed our name to Compose to reflect the fact that we are hosting other databases besides MongoDB. Oops, went a little too fast there. We currently offer 9 databases and developer services. We released MySQL about a month ago, and we launched Scylla about a week before that. And of course, today we're here to talk about ScyllaDB. So please check it out on our website and check out all of our services. If you're new to Compose, we offer everything free for your first 30 days. All right, and with that, we're going to move on to today's topic. As I mentioned before, today's presenter is Eyal Gutkind. He's a solutions architect at ScyllaDB, and prior to that has held various product management and engineering roles with Rantis and DataStax. As y'all will show, ScyllaDB is a very powerful replacement for Cassandra with a much lower hardware cost and higher performance. He is, speaking of bravely calling in today and joining us, he is calling in from South Korea, which I have to commend for him agreeing to do a webinar at this hour for him. I think it's about 4 a.m. for him, or 3 a.m. If there's any delays or any kinds of audio issues or connection issues, it's probably because he's calling in from a remote place. So please be sure to post any questions and bear with us as we go through. But if you do have any questions, if anything was missed, just go ahead and pop a question in, and we'll try to answer that as we go. And then any broader questions that you have, we will try to get to at the end. And with that, y'all, I'm going to pass this on to you. I'm going to pass the controls on to you. 1 second. There you go.
Okay, I think I am good to start. So thank you, John. Really, it is a pleasure to be here, and thank you for providing us the opportunity to present at Compose. And the time is great, by the way. 4 a.m. It's a best time to do a webinar, I think. So once again, thank you everybody for joining our webinar. In this webinar, we are covering the following items: an overview about Scylla, why Scylla Compose and the advantages of DB-as solutions, the way Scylla operates and works under the hood, the different ways users can migrate their applications from legacy solutions to the Scylla database. And we will cover some examples created by Scylla users. So let's start diving in. First, let's talk about the origins of Scylla. Scylla's roots are with the core development of innovative hypervisors. Scylla CTO introduced today's most popular open source hypervisor, pushing the industry into developing a better cloud infrastructure and more efficient compute resources. Today, the KVM hypervisor is present in almost every cloud platform, whether it be a private or a public cloud offering. Scylla is aiming to do the same. We built Scylla to use infrastructure and resources available today in the most efficient way. So let me tell you about our people a little bit. So Scylla is a distributed company around the world. We have developers in Asia, in Japan and China, Europe, Middle East, North and South America. The level of talent within Scylla is second to none. We help develop the leading database in the market, and we are working with the most capable resources out there. So next one is going to talk about why DBAS, you might ask. So the first thing is developer productivity. DBAS solutions such as Compose release the developers from the task of maintaining and provisioning their database. Operation simplicity is the second one. Database operators are required to answer developers' need with a performance and resilient database. DBAS solutions reduce the operator's fatigue, offloading routine tasks such as provisioning, backup and restore, scaling, and more, allowing the operators to focus on the business requirements. The business resiliency is the third one. Loss of data is not an option today. DBAS solutions provide business owners with a simple and cost-effective database provisioning, while guaranteeing geo-replication as well as periodical backup and restore. The last one is faster scalability. Basically, you want your database to keep up with your growth and your business. DBAS scale faster. Adding a node or storage is just one click away. So for the last 2 months, you can use Scylla over Compose. Compose is offering multiple platforms, as John alluded to, for developers to create applications without the hassle of installing and maintaining the platform. You can find different databases offering, and one of them is Scylla. So how you do it? Well, your first step is register to Compose. You will get a 30-day full access trial environment. Next, you're going to log into your account. Third, choose ScyllaDB, the region that you want to be deployed, East, West, Asia, etc. And choose the size of the data you're going to be using. Click Create Deployment, as you can see in the blue button down there. You give it a minute or two. There are some nice teasers on the screen. And voila, you will be prompted with a username and password that are provided to you from the deployment console. At this point on, you can start and use ScyllaDB on Compose. Basically, from this point, you can access Scylla through your application drivers or the integrated CQL tool. Make sure you provision the needed amount of data for your application, so you will be able to use it efficiently. In the next sections of our presentation, we will be covering the way Scylla works and interacts with applications and tools in the NoSQL and big data ecosystem. So let's first take a step back and understand the philosophy behind Scylla. ScyllaDB is an open source, high-performance database. We redesigned the database from ground up while maintaining compatibility to the popular Cassandra application protocol, creating basically a drop replacement database for applications that are using Cassandra today as their data store. The advantages of Scylla are basically the predictable low latency, the high throughput capabilities, and the reduced operational complexity. A single node of Scylla provides the same capabilities that require a handful of nodes with a legacy solution. So what's the edge, you might ask? So basically retrieve and update information in a fast and reliable manner is our goal. Scylla is the fastest database, making sure your application can scale and support growing demand for information without incurring high latencies or drop mutations of information. Scylla is highly available and fault tolerant to network partitions, and Scylla is built on a masterless architecture, where each node holds part of the information and replicates to adjacent nodes. The architecture guarantees that in the case of one node failure, data can be accessed and business can continue as usual, while operators replace the faulty node. Scylla is easy to manage. Scylla is implemented in C++. The powerful implementation of this framework reduced the amount of knobs that database operators have to tune to gain control of performance and resiliency of their database. More than that, while deploying, Scylla will learn the capabilities of your nodes and make sure that the information, the infrastructure you're using is used efficiently. We will touch basically the details on how we do that in the next slides. Scylla is supporting a NoSQL ecosystem. Scylla works seamlessly with the analytics tools such as Spark and Presto, and with time series database such as KairosDB, and graph database such as Titan. Since Scylla is a drop replacement for Cassandra data stores, Scylla supports the open source versions of the Cassandra drivers. So how Scylla is different? Scylla will look into your cluster and to understand the resources available to support your users' queries. The database back office quote unquote workloads, and the resiliency and recovery features. Scylla uses every core you can provide from the server, making sure those big dollars that you've spent on infrastructure are not sitting idle. Scylla uses its own task scheduler. We'll touch that one in a bit, to make sure that the user performance is maintained under the extreme load levels. We also manage memory to make sure that any amount of DRAM provided to that server can be used for data cache, thus able to deliver most of the queries from RAM and minimizing the number of queries that are being hitting with the slow media or the network. Scylla also supports high-performance networking platforms and deliver efficient data streaming capabilities between the nodes. We ensure that the fast recovery and sub-millisecond latency are available for our users. Let's deep dive a little bit more. Scylla ability to support a sharper core architecture. This is one of the core items that we will be discussing the differences about Scylla. Basically, in today's modern compute systems, the user can take advantage of the high number of cores you have in each server. However, not all applications are optimized for the high numbers of cores that are available for you. The application threads will try to compete, as you can see on the left-hand side, for a single core, randomly chosen, and that, you know, it might be sitting idle, and then causing contention between the different threads on the poor core that was randomly selected. Scylla, on the other hand, as we'll see on the right-hand side, will learn the nodes in its ability, which are available, the availability of a system that is available for us, and make sure it deploys a shard, which is a computational unit per core provided. It is possible for the operator to control the number of cores allotted to Scylla, just in case the operator would like to reserve some of the cores for a different workload. With Scylla shard per core, each core operates as an autonomous compute unit, providing services to the database clients or the backend processes. This way, the different shards are not competing for the same resource and making sure one shard is not causing the other shards to starve or crash. How it is going under the hood? Well, Scylla has its own I/O scheduler. The dedicated scheduler that we have help us prioritize processes in a fashion that makes sense to the database operations. In many cases, legacy solutions will start a backend process exactly at the moment that it's critical to the application. Such a stop-the-world behavior is extremely painful to the application, to the extent of a complete refuse transaction. Users might believe that with only throwing more hardware on the issue, they can solve the stop the work problem. Well, we're not sure about that. Looking on I/O concurrency, you will find that even if you add more servers, you are still limited to the maximum effective concurrency of your I/O, in which beyond that max efficiency point, your I/O is actually clogging your system more by incurring more latency to support the registered transactions. Scylla, on the other hand, will classify the different tasks and prioritize based on the system capabilities, and to some extent, user preferences if you have ones, making sure that customer's query is taking precedence over back office processes when it's actually needed. While that is available to you, it reduces the chances that to run into such a high latency cases. Database operators can fine-tune those priorities. However, we highly recommend that you let Scylla learn your I/O and network capabilities to use the resources in the most efficient way. As we mentioned before, Scylla uses a programming framework that is capable of assigning a sharper core. The framework is called C-Star. It's an open source programming framework that was developed by the Scylla team. One of the advantages of C-Star is the support of advanced networking capabilities, and the user space networking stack makes sure the application's network transactions are delivered with a minimal latency between the different nodes. With C-Star and Scylla, we make sure that the kernel less efficient stacks are not part of your application latency burden. So how will this translate to actual results to the database users? Let's talk about a little bit about performance. We benchmark Scylla against Cassandra. We use the YCSB, which is the Yahoo Cloud Service benchmark. The YCSB benchmark is a collection of workloads that represent typical web and enterprise transactions workloads in today's modern data centers. The benchmark tries to inflict certain amount of transactions into the cluster. The benchmark then logs the actual perceived transactions before dropping the request and asking the client for a retry. The benchmark also logs the latency elapsed for the query that to be served. This information is actually available in the smaller lower part of this chart. In our testing of Scylla on bare metal solutions provided by IBM SoftLayer, we measure the performance of Scylla versus different number of Cassandra nodes. In all our testing, we use the same hardware configuration against the stock Cassandra 2.1.8 implementation. As you can see, to be able to sustain the same workload that Scylla handles with only 3 nodes, the Cassandra implementation had to provision 10 times more nodes. Not only the operators had to manage and maintain more servers, but the actual latency results for the Cassandra implementations are lagging behind. While Scylla with only 3 nodes implementation was able to maintain query latencies below the 5 millisecond mark, the Cassandra latencies were 2 to 5 times higher than that. Applications using Scylla will be able to provide better experience to the users while helping the operators manage a smaller system footprint. So to summarize, the ability to provide users with a more performant and scalable solution translates to operational users' ease. Operators will be able to show significant savings in their OpEx expenses by reducing the number of servers they operate. The actual management costs are reduced as there is no need for complex tools or services to maintain your database cluster. With a fewer number of servers, the probability of a server failures and the need to replace it are reduced significantly. At the end of the day, the capabilities translate to higher value of your data that the organization is using on a daily basis. On the next part, I will talk about administration. So a crucial part of maintaining a working database is the capability to understand and monitor its behavior. Scylla provides an open source monitoring solutions to help you maintain a cluster in a good health. Scylla utilizes the server hardware metrics in addition to Scylla specific metrics to provide operators with a complete view of the happening in the database. Operators can learn about data cache utilization as well as compaction processes that are ongoing, or network traffic going through their network, through their cluster as well. Scylla provides a fine-grained metric to understand the load on each node that you have in your cluster. These metrics help the operator to better size the cluster and scale when it's needed. Scylla do not expect the operators to learn a new maintenance tool, by the way. If you are a familiar Cassandra operator, you will find the same node tool command operating with Scylla. To augment the JMX protocol, we provide a RESTful API using the same semantics as used with node tool. The following is a snapshot of the monitoring GUI provided with Scylla. A user can custom the views, make sure they are on top of the most important metrics of their cluster, whether it be disk I/O or cache eviction rates or compactions that are going on flight. The next thing we're going to talk about is about compatibility and migration path. Well, Scylla is a drop replacement for Apache Cassandra. Scylla supports the same SS tables format as supported by the Cassandra 2.1.x versions. Scylla can use Cassandra YAML file, if you have one for your Cassandra cluster, to provision a Scylla cluster with no changes required. Scylla will work with the same drivers and protocols you are familiar with from your Apache Cassandra community. Scylla supports also both CQL and the legacy Thrift protocol, so there is no need for you to actually modify your application when you're moving to Scylla. And we use the same management command line to support the same monitoring protocol that you're familiar with from the Apache Cassandra community. A vibrant ecosystem is a crucial part for Scylla Philosophy, and Scylla supports the various open source Apache Cassandra drivers as well as innovative third-party tools. Tools like Apache Spark, Presto, for fast analytics on top of Scylla database. And for users with time series data, we maintain a persistent data store on ScyllaDB for solutions like Kairos DB. If you are into graph databases, using a Thrift protocol, you can connect your Titan database to Scylla and gain the needed performance boost your graph solution requires. The next item is migrating from Cassandra to Scylla. You have your currently working cluster. You will need to snapshot the Cassandra cluster and move the SS tables to Scylla. Scylla, as I said before, supports SS tables format for version 2.1.x. Once the snapshots are in place, using your application, you create a dual write, one to Cassandra and the other one to Scylla. Also make sure you are comparing the query results obtained from your legacy Cassandra cluster to the query results from Scylla. In this case, the application is making sure the information is maintained in both clusters and the results are coherent. Once you find the Scylla cluster fully coherent with your Cassandra cluster, all you need to do is disconnect the Cassandra cluster from the applications and serve the application directly only from your Scylla cluster. This is that simple. Scylla Enterprise includes tools to help you migrate from Cassandra cluster to the Scylla one if the application modifications are not permissible. The CQL proxy is the add-on to the Cassandra cluster. The proxy will make sure your transactions to the Cassandra cluster are forwarded and logged into the Scylla cluster. The proxy eliminates your need to maintain two connections to the two different clusters. The CQL proxy will reduce the amount of traffic from your clients to the cluster itself. As I said before, the CQL proxy is part of Scylla Enterprise products. And again, once you find Scylla cluster fully coherent with your Cassandra cluster, all you need to do is disconnect the Cassandra cluster from the application and serve the application from your Scylla cluster only. Again, this is that simple. The last option is available to customers is a stop, install, and start. In the previous two examples, no downtime occurred during the actual migration. And the database, the legacy Cassandra, and the new Scylla cluster were operational at all times, allowing the application to continue and be served by the databases. In this case, we shut down gracefully the Cassandra cluster with flushing all the information to the SS tables. We disconnect the application from the Cassandra cluster and transfer the SS tables to the new Scylla cluster. We start a Scylla cluster and connect the application to the Scylla cluster IP addresses and reduce the application's resume the application's operations. In the next section, we will show some of our customer results with Scylla. A couple of months ago, we hosted a Scylla Summit in San Jose. Our partners and customers were presenting their results with Scylla. The following information is part of the presentations shared with the public. You are more than welcome to visit our website. It's ScyllaDB.com to learn more about their use case and the results they got. So the first case is from Outbrain. Outbrain is a content recommendation engine using Scylla to support its document store. On the top part of the screen, you can see the legacy results of Cassandra deployment. The upper part represent Cassandra, showing peak latencies shooting to the 200 milliseconds ranges. It's actually causing around 500 timeouts to the applications. Each timeout is a results in a 1 second stop the world. The Scylla implementation is able to provide sub 8 millisecond latency for the same workload at the same times and peaking at the 10 millisecond ranges. The outcome, basically for the document store of Outbrain, is a 20-time reduction in latency. The savings in latency translates to a better user experience and efficient usage of the system. So, with the same use case, in order to reduce the latencies from the Cassandra part, Outbrain has fronted the Cassandra cluster with a caching layer, thus reducing the load from the Cassandra cluster. Adding a caching layer increases the complexity of the system and puts more burden on the OpEx cost and the management complexity. We can see that even with the caching layer in front of the Cassandra cluster, the max latencies results for the Cassandra ones are roughly 4 to 5 times higher than the latencies for the Scylla cluster. The average latency for Scylla is half of the combined, basically cumbersome solution of Cassandra and Memcached in this case. It is obvious again that with Scylla you can reduce the operational cost while providing your users with a better user experience. The next use case is coming from Kenshoo. Kenshoo is an online advertising company used by brands and agencies to handle more than $350 billion in annualized client sales revenue from ad spending across the web and mobile devices. The information we are presenting relates to operational, basically back-end office workloads, how you actually manage and operate a Scylla and Cassandra cluster. A repair process is a process used in every distributed, eventually consistent system to make sure that all nodes have the same coherent data. The process involves data streaming and comparisons of data between the distributed nodes. As can be seen in this comparison, Scylla repair process takes 1/3 of the time that takes a Cassandra cluster to do that. The smaller time frame means that less hiccups in the latencies to the clients and we are reducing the overhead on the cluster itself. The next one, it's a cleanup process. Basically, cleanup process is a repair process used to remove unwanted data from a node. For example, when we add a node, the information in the cluster is redistributed across the different nodes, and the result is fewer partitions per data node. However, the old nodes, quote unquote, still hold the quote unquote old data that is no longer needed. A process is required to clean the unneeded data from the and free up the space without losing any part of that information. With Scylla, this process takes roughly 1/10 of the time it takes Cassandra to complete it. The result, again, is faster aggregation of capacity with minimal to no impact to the currently running nodes. The last comparison Kenshoo did is to measure the time it takes to compact information. Since Scylla and Cassandra to that extent are an append-only architecture, there is a need to evacuate deletes, also called tombstones. The process makes sure that any deleted records are removed from the SS tables, the persistent file system on the disk. And this is a crucial part to maintain a working cluster for the long run. As you can see, the same compaction process takes 9 times longer than with Scylla for the Cassandra cluster to do that. That means, again, that maintenance costs to support Cassandra cluster are much higher, as you have to make sure you have enough capacity in each node to hold all this data while you are compacting. The last use case that we are going to show you is coming from Samsung SDS, which is a subsidiary of a Samsung Group that provides information technology services. The following cover Samsung's SDS customer use case for both read and write workloads. The testing includes scalability and performance testing of Scylla versus similar solutions. By the way, TPS that you see here are transactions per second. Samsung SDS covered 2 use cases. Each had a different data model with different workload characteristics. In this chart, we can see workload number 1, performance, which is a read dominant one. The performance for Scylla is obviously better, while serving more requests also provides a better latencies to the user's queries. In the following test, Samsung SDS summarized the performance under the 2 different workloads. As we can see, both throughput and latency results are superior when using Scylla. Again, it means reduced operational cost and more user-friendly operation. In the following test, Samsung SDS summarized the performance under the 2 different workloads that you have seen. As you can see, the latencies are superior when using Scylla. And the last one is stability. Basically, Samsung SDS summarized the performance under the 2, as you can see, both throughput and latency results are superior when using Scylla. And the last one is, again, as I said, is stability. You want to run your database for a long time. CPU usage as well as the transaction and workload should maintain the same across the heavy load. What the guys at Samsung SDS did is running the servers for 5 days. What you can see in the slide again is no reduction in the performance over the longer run. We have more people using Scylla, and we would like to have more people using Scylla as well. So if you are looking for a good database solutions, you can use Scylla yourself. Use Scylla at Compose is a simple task, as you can see. You have 30 days to test the offering at no risk. Take advantage of this great opportunity. If you need to learn more about our customers' use cases, check out our summit presentations. Just Google Scylla Summit in your browser, and you will find out the videos that are available on YouTube. So to summarize, we saw how you can use Scylla at Compose very easily. With 2 clicks, boom, you have a performant database at your fingertips. Reduce your OpEx while maintaining the same workload and providing your users with a better application experience. Don't change your application. You can just port your existing Cassandra application to Scylla, whether on Compose or on-premise, and it just will work. So how do you contact us? Contacting us is very, very easy, and we have various avenues you can do that. First, we are available on the web, so ScyllaDB.com. We are also on Twitter, so at ScyllaDB. You can ask us questions about Scylla on our mailing list. Please subscribe to the mailing list to receive the latest updates about Scylla. And again, thank you for attending this webinar. We will be happy to answer some questions that you might have at this point. And thank you again. John?
Yep, let me just get my window up here.
Okay.
All right.
I'll have to give you back the...
All right, so are you able to see the questions screen? My GoToWebinar panel just crashed.
Oh, okay, I see. Okay. Let me click on it. Yes. All right. Give me a second. I'll see if I can do that. Where is those questions? Cannot see that video part.
All right, there we go. It should be up now.
Okay, okay, now you're good.
Sorry about that. My for some reason GoToWebinar crashed. I had to reboot it, but sorry about that. So if there are any questions, please go ahead and post them now. I actually need to reopen my questions window, and just go ahead and send your messages in. And let's see. There's also on the screen, as you can see, I posted links to ScyllaDB. If you want to follow up with them on questions or IL specifically with questions, you have his email address here. You can follow them on Twitter. If you have any general questions about our webinars, you can email us at webinars@compose.io. We did have one question at the moment, which is any thoughts about community and DataStax's latest stance?
Well, I would not refer to DataStax's operation. I think it's something that should be asked for the DataStax team. I think DataStax did an amazing job creating a great community around a solution like Cassandra. It's a popular solution, very performant. Really is a breaking technology in terms of innovation when it started. We think that Scylla is the next generation of Cassandra, basically the next step that you have to move on in terms of the ability to take advantage of the great technology you have today in terms of performant servers, cloud offerings, NVMEs, SSDs. This is how you progress and make more efficient solutions today. ScyllaDB can take advantage of those resources, while legacy solutions cannot. The Cassandra community is a big community. It has many supporters, and we hope that it will continue.
Great. This actually question goes with the one that we just asked, which is, can you mix and match, or can I mix and match a Scylla cluster with a Cassandra cluster?
Well, you cannot do that, and the reason is that our GOSSI protocol is different from the Cassandra one. So there is no option to mix and match same nodes on the same cluster. As we saw in the presentation, you can stay with your Cassandra cluster as it is and add and create a Scylla cluster, and your application can do the writings to the two different clusters if you need to do that.
Great. And one more question is, what are the requirements to install Scylla in terms of system components like hardware, operating systems, and so forth?
Great. Basically, we support different platforms, whether it's going to be on-premise or cloud or any type of private cloud solution that you might find out there. You need a multiple core system. You need a Linux operating system. We support CentOS 7.2 and above, or L for that extent, and Ubuntu 14.04 and above to create a Scylla cluster. I recommend at least 3 nodes to have the resiliency features of this architecture available to you. And if you can, and we highly recommend you to use SSDs as a performant I/O, so you can take advantage of the capabilities that I just mentioned about Scylla. If you really want to reduce your systems overheads, you use fairly available today's hardware to make sure that it's easy to deploy on it. And using Scylla with such hardware is so easy because Scylla will learn the capabilities you have in each server automatically. And then we'll be able to use all that goodness that you have brought into that server to your advantages. And don't leave anything to the residues.
Great. And I actually have a last question myself, which is, can Scylla be used with other deployments on top of Compose, such as Elasticsearch?
Oh, yes, definitely. Basically, I was doing that myself as well. So yes, we see it's a very common use case. You put Scylla with Elasticsearch, so you have a full text search on your information together with a performant database. It's so easy. It's amazing. I was really just connecting my clips, one connection to the Scylla cluster and the other one is to Elasticsearch, and just it was flowing in an amazing, easy way. From my perspective, point of view as a developer, I couldn't feel any difference whether it's going to be anywhere in the world. And it was, I don't know, as I said, 2 clicks for the Scylla ones, 2 clicks for the Elastic one, fire up my clips and go for it. I didn't have to manage anything. That easy. It was a blaze, and it was fun experience from my perspective.
Well, great. That's always good to hear. Great. Well, there's no other questions at the moment, so I think we'll wrap up. I appreciate everybody hanging on, even though we had a few audio problems, and then GoToWebinar decided to crash on me at the end there. But I wanted to thank you all for his time, and thank everybody for attending today's webinar. It does conclude our presentation. Please consider giving ScyllaDB a try today on compose.com. It takes just a few minutes to deploy it in a 3-node cluster. If you do have any general questions, please send them to the email addresses I had on the previous screen, and we'd be happy to answer them. And that's it. Thank you all for attending.
Thank you.